Hi, today we're going to be making a simple circuit that can detect when it's dark out and can switch on a load completely by itself. For that, we're going to be using a solar panel and a couple other capacitive components. Let's get started. So the way this circuit works is that when it gets dark out, this little solar cell will pick up the light change and will turn a light on, depending on if you wired it up correctly. You also need to know how to solder. Well, I guess you could build it on a breadboard too. So the way this works is that we're going to have our solar cell here, and this is our solar cell, and positive is going to go into our transistor. Now this transistor is going to control the relay. And here's my poorly drawn relay. So that gets, this is the supply voltage, and then this is going to be our little photocell, solar cell. Now it's connected to ground. So I guess we'll have a flyback diode. Okay, this is a little bit more complex than I thought. But whatever. It's pretty easy still. So that's our circuit. I think. Maybe like a resistor there or something. I don't know, I'm just making this up. So when the solar panel gets power, it's going to turn the relay on, which will flip the switch over. So this is a common, this is normally closed, normally open. So this could be connected to like a light bulb or something. And then this could go to ground. This could connect to the supply. I don't know. That's a terrible V. And when it gets power, it can switch on and turn the light bulb on. But if you want it to come on at night, you could do this so that during the daytime, the relay's on, and when it gets dark enough, the relay switches off, turning the light on. I'll clean this up in a minute. Alright, so here's the new circuit I designed. I have a new appreciation for teachers. Writing on whiteboards is difficult. We have our solar panel here, which could be any cell. We have D1, which is some sort of diode. I'm using it as a flyback diode, so like a 1N4007 would work. We have a relay 1, which is going to be our switch. That could be any relay. I'm using a 3-volt relay because that's what I have. We have an AC supply. It doesn't have to be AC, but if you want to control a lamp, this could be like an outlet. It would go through the relay and control the load, light bulb, motor, whatever you're connecting to it, as long as your relay is rated for it. 2-1, some sort of NPN transistor. 2N2222 would work. 2N3904, TIP31C, any of those would work. And that's it. That's how it works. I can just build it on a breadboard and test it out. Look, it's snowing. Wow. Did they purposely make it so that relays don't fit into breadboards or circuit boards? It's so annoying. Alright, so now we get to test the circuit. It should click when I close and open the solar panel. Turn it on. Oh. Really, man? Oh. Well, actually, I don't think I really needed that resistor. Should just be able to tune it. Oh. Really? That too? I broke it. Maybe it still works? Or not? Oh. Okay, now I think it's dead. Okay, let's try this again. I'm using a bigger solar panel now because a smaller one couldn't produce enough power to turn on the transistor. So, now, Can you hear it? The relay clicks on and off when I cover and uncover the solar panel. Pretty cool. There's also a fine line of how this thing works. Here's that. You probably could have guessed, but this isn't the most practical circuit to use in your projects. More commonly used is an LDR, or a light-dependent resistor, which are much smaller, about that big, and much cheaper too. They are actually basically just resistors that change their resistance depending on how much light they receive, which is also pretty good for building circuits like this. You can control any load up to whatever your relay's rating is. Mine here is a 15 amp relay, so anything up to 15 amps I can control, AC or DC. Thank you for watching. If you enjoyed this video, please consider subscribing and hitting that bell icon below this video. If you have any questions or comments, as always, leave a comment below. More comments, more better. Okay. Anyways, see you next time. Happy holidays.